All right, working with inequalities today. So quick review, and we're going to solve some problems together. Inequalities, so we've got less than symbol. We can have less than or equal to, greater than, or of course greater than or equal to. Those are the different symbols that pop up. Remember the difference, if it's got equals in it, then those endpoints can be included. If not, it's just going to be open circle. And again, this ought to be pretty familiar to you, I hope. So you solve these basically just like equations we've been solving with equal sign. The only difference is your answer is going to be a number set instead of a single number. So let's look through these. Solve 3x minus 6 less than 27. So whatever we plug in for x, we want this thing to be less than 27. Well, same thing. Let's get x by itself. So add 6 to both sides. So 3x is less than 33. We want x by itself, so let's divide that 3 over. X would be less than 11. So that would be my solution. Now I'm just going to graph it to show you what that would look like. So in fact, it's right here below. Let's go look at it. X is less than 11. So that's everything below 11, right? So that's got to be an open circle. 11 is not included. If it were equal, then I would close that, and this could be everything below it. So we can shade. There's different ways to do it. So can you see the graph that matches? Of course, it's this one, isn't it? Less than 11. This would be less than or equal to. That would be greater than 11. This would be greater than or equal to. Not too bad, right? One thing to look for, I think we'll run into it in an example. Really, the only difference when you're solving these over a regular equal sign is if you divide by a negative. Okay, if you divide a negative by both sides, then you need to reverse your inequality symbol. Okay, reverse your inequality symbol. Okay, let's keep going. Let's look at some more examples. Solve and show the answer. Okay, so let's do this. So notice we've got some different stuff going on here. Just a little bit bigger problem than the last one. And our inequality is on the right side. Not a big deal. Okay, so we want to get this n by itself eventually. There's different things we could do here. I could just distribute this. I could divide the 2 out at the start. I'll just go ahead and distribute. So 12 greater than or equal to 6n plus 2, right? 2 times 1 plus 22. And again, my goal ultimately is to get this n by itself. Now, there's different ways you can tackle this. Okay, if you don't do it exactly the same as me, it's fine. But to illustrate something, because I've already got a bunch of numbers here, I'm going to take my 6n over here and bring 12 over. So let's subtract 6n, and I'm going to subtract 12. So I'm going to have minus 6n over here, and I'm going to have minus 12 over here. So now I have minus 6n is greater than or equal to, well, let's see what we've got. So 2 plus 22, that's 24, minus 12. So I have 12 on that side. Now I'm going to divide my negative 6. Divide my negative 6. Now here's an example I was just talking about. I'm dividing by a negative, so I'm going to reverse this symbol. So n is going to be less than or equal to negative 2. And that would be my solution there, okay? Which of the following is the correct solution to the inequality? Well, let's clean this up. So 2x, notice I've got x's on both sides, so distribute 2x plus 2 plus 3. Let's get my x's on the same side, so I'm going to subtract 2x over. Notice what happens here. I've got 0 is less than 5. 0 is less than 5. Well, that's a true statement, isn't it? 0 is less than 5. And I don't have any x's left, so that means that for every value of x you could think of, anything you could plug in for x, this is going to work. And so all real numbers is going to be my solution here. Now, if my x's disappeared and I got something that was not true, there would be no solution. Okay, let's talk compound inequalities. Compound just means you've got multiple inequalities in the same thing. You've got and statements where it's got to be true in both, or you've got or statements where it can be either or. And you just solve these. This is kind of a 2-for-1. So let's get d by itself. Let's divide by negative 4 divide by -4. Now notice I'm dividing by a negative, so we have to reverse that. So d would be less than -2. Now let's solve this equation. So again, I've just got two separate equations. Dividing by 2, d is greater than -3. So d is less than -2 and d is greater than -3. Alright, so notice we just have an and. Now one good thing I think to do is just make a quick sketch. Visualize what you just did. So greater than, or d is less than -2. So that would be everything that way, right? Greater than -3, everything that way. Oh, it's going to be a sandwich here. Now, you get familiar with these, you'll know that. But the graph can help you visualize this. And so you could write your answer like that, or you could just write it like this. D is going to be sandwiched in between -2 and -3. So there's different ways that you could write your solution. Okay, nothing wrong with this, but we could write it here as a compound inequality as well. Okay, what if it's an or statement? Well, very similar. Just solve both equations. So we're going to add 2 to both sides here. So b is greater than 18. And for this one, let's divide 3. So b would be less than 18. Woo! Less than 18 right there. So b is greater than 18, or it's less than 18. Well, that's interesting. So b is basically everything except 18, right? It's everything that way, and it's everything that way, so it's everything except 18. And so different ways that you could write that. You could write it like this, because they happen to be the same number. Oh, I'm sorry. Plus 2, that's not an 18, that is a 20. Okay, that'll be a little different. So we've got less than 18 right there, and then we've got 20 over here, don't we? So we actually have 20, so just ignore that. Sorry about that. So everything that way, so it's everything this way or everything this way. And so we could just say, hey, b is less than 18 or b is greater than 20. And in the future we'll probably find different ways to write that as we continue on in math, but I think that's all they're going to be after today, okay? Alright, one more little word problem for us. Which inequality should be used to solve the following problem? So again, don't be intimidated just because you see a bunch of nouns and verbs up here, alright? The crowd that heard the president speak was estimated to be 10,000 people. The actual size could be between 750 more or less. What are the possible values? So there's a range. What's 10,000 minus 750? Well, that's 9250. What's 10,000 plus 750? So 10,750. So here's the low end they think we're there. Here's the high end. Which one of these estimates would be between it? Well, let's think. It could be up to and including that, and it could be down to and including that. So again, I didn't even look at the choices. Notice I came up with what I think the solution should be. Let's go look at the choices, see if we find that one that matches. Hey, it looks like letter C matches there. Okay, notice the same numbers here, but that would be, this would be less than that. Well, no, it could be up to and including, right? So just the way you put your inequalities can make a difference. Again, not too bad, I hope. Pretty straightforward working with inequalities. As always, though, if you have any questions, please don't hesitate. Reach out to me. I'm here to help you.